Okay, welcome back to the last video for the first week. And again, in this video, I want to go through some examples of failures, right? What happens when you can't maximize or minimize your objective function? And so the first one I want to take you through is that example from the fourth lecture, or the fourth video, regarding, what happens when the slope of your objective function and the slope of one of your constraints is the same, right? Because then that's the situation where the objective function will lie right on top of the constraints, and you're going to have multiple points that will satisfy that objective function. So let me take you back to that problem. That was min 6x1 plus 24x2 subject to x1 plus 2x2 greater than or equal to 3, and then x1 plus 4x2 greater than or equal to 4, and then of course we have x1 comma x2 greater than or equal to 0, right? My non-negativity constraints. Okay, so we set this up. So here's x1. I'm trying to set up the same way I did in the previous videos. So here's x1. Here are the parameters of my objective function. Here are my choice variables. And then, of course, here's the objective function itself. You have to spell it right, though. Okay, and then, of course, you have your constraints. Come on. I'd prefer to do it this way. Constraint 1, 2, and 3. I just have 2. Okay, there we go. Okay, so here, 6 and 24. I'm going to put 1s in as placeholders. And then my objective function, of course, that's my sum product function. So here's mine highlighted already because I've been using this computer. So I'm going to highlight my parameters. That's one array. Highlight the choice variables as a second array and hit OK. Pardon me, let me move my notes. Now my constraints. So here's a 1 and a 2, and that's got to be, what did I say, greater than or equal to 3. And let me minimize these so I can get everything on one screen for you. Now, I'm going to minimize this as well. Okay, there we go. And then the second constraint, right? 1, 4, greater than or equal to 4. And then remember here I need the sum product, right, of my choice variables and the parameters for my constraints, right? Because I'm going to compare these numbers, whatever I get here, to these numbers, right? So I'm going to get that sum product function. Here's the choice variables. Parameters of the constraints, and then same thing here. Okay, choice variables, parameters from the constraints. Voila. Okay. So now I'm ready. Let me go to solver. So data, solver. Okay, let me move this over here. So what's my objective function? That's this cell. And I want to minimize this function by changing my choice variables, and then of course subject to these two constraints, and they have to be greater than or equal to these numbers. And I'm going to hit OK. And then I've got this box checked because these are my non-negativity constraints. I want simplex LP, and I'm going to hit solve. Okay, and I'm going to stop here because this is one of the troubling things with Solver, is Solver actually found a solution to this problem. And that solution is one of the points, one of the kink points that I told you about. This is the kink point 2.5. If you go back to that fourth video, you'll recall that I said, look, the solution to this problem is any point on the line from point 2 0.5 all the way down to 4, 0. Right? So any point on that line would satisfy this constraint, or these constraints, and return the minimum cost. And so what Excel has done here is picked one, right? It's picked one of those kink points. And to show you that, remember that the other kink point was down at 0.40. So if I put in a 4 here and a 0 here, look, I've satisfied everything, right? 4 is greater than or equal to 3. 4 is greater than or equal to 4. And notice that my cost is still the same, right? It's 24. So if I go back, 2 and 0.5, 24. Right, so the point is, both of these points, the 0.2 comma 0.5 and the 0.4 comma 0, satisfy this problem. I've reached my minimum cost of 24, and both of my constraints are satisfied. So what I'm trying to point out is one of the troubling things with Solver is that you'll never know if you have multiple points that satisfy your problem, right? Because Solver will give you one of those kink points. So I just wanted to point that out. It's a bit unfortunate. Okay, now I want to move on. And here I want to give an example of an infeasibility issue. So I'm going to take you back, I think it's to the second video, and we were dealing with this problem. We were going to maximize 5x1 plus 10x2, and subject to x1 was less than or equal to 12, x2 was less than or equal to 8, and then x1 plus x2 is less than or equal to 14. And then, of course, I had x1 comma x2 greater than or equal to 0. All right. And here, so just bear with me. I want to solve this. Okay, so here I have my parameters. You know what I should do? Just do this. Copy this. I'll have to type everything again. Okay, so 5, 10, 1, 1, sum product. Okay. And then this time I need to add a constraint. Okay, so the first one, this is just 1. The second one, that's 1. And then I have 1 and 1 here. Okay, and then these are all, less than or equal to, so let's use those. Okay. And then we had 12, 8, 14. Okay. All right. And so now I need these. So again, I'm going to use that sum product of my choice variables and the parameters for my constraints. And this time I'm going to use that anchoring just so I don't have to keep using the sum product function over and over again, or reusing it. So here are my choice variables. Here are the parameters for the first constraint. And then remember, I think I talked about this I'm sure I talked about it in an earlier video, but my recommendation here, actually I don't want to, there you go. Anchor your choice variables, right? See how these are highlighted in blue? That's your choice variables. And then the red, those are the parameters, the constraints. I recommend, just to speed things up, is to anchor your choice variables because they always have to be in these sum product functions. And then you can just copy that down. And presto, there you go. All right. So recall that when we solve this, right, we got the following. So here is our objective function. We are maximizing this. We are changing our choice variables. And we have to satisfy these three constraints. I make sure this box is checked. Simplex LP, hit solve, hit OK. And this is the answer that we got way back when. We're going to produce 6 units of good 1, 8 units of good 2, and 110 units of, I'm sorry, we have $110 worth of profit. Okay, well now I want to make this infeasible, and I want to show you how this works and what happens to Excel. So now let's say management comes back and says, wait a minute, we have to produce at least 15 units of good 1. Okay, so notice one of the problems here is that for a max function, this is a greater than or equal to, not a less than. So that's kind of a first hint, right? And so now if all I have to do here is just go back and flip this and change this, right? And now I can just solve this. Well, what's going to happen? So everything is the same, except I need to redo my constraints. So this now is 6, but this has to be greater than or equal to 15. And then I can just highlight these two, less than or equal to these two. Okay. Got this box, Simplex LP, hit solve. Uh-oh. See, big red question, exclamation point, bad. Solver could not find a feasible solution. Uh-oh, well what happened here? Well, the idea here is that you actually have 2 feasible regions. And I just wanted to draw this out for you to help you see it. Now this is in your book, all right? But I think it's instructive to take a look at it real quick. Okay. Okay, so just real quick, what's happening? All right, bear with me. How about, okay. All right, now just hold on. There we go, wow. I didn't need a graph that big, sorry. All right, so, here's x1, here's x2. All right, now x2 less than or equal to 8. Right? And so that's this area down here. And then here I have x1 plus x2 less than or equal to 14. Remember, that was just a straight line that went from 14 to 14. And so right here now is my feasible, so far this is my feasible region. Well here, here's what I'm trying to get at. This constraint here, I did that wrong. Sorry. This constraint here, x1 greater than or equal to 15, well, that's all this, right? And so here is the problem. What's going on here is essentially I now have 2 feasible regions that must be satisfied. And of course, the problem is a straight line is may not solve both of these. Right, even if it was going through, even if I had a straight line that went like this, I'm still going to run into problems because am I over in this region or am I, way out here, right? So that's what's going on graphically when you see the infeasibility error, okay? So with that, I have one more to show you and then we will be done with week 1. And this last one is an unbounded, okay? And so for this one, I'm actually going to use the example in your book because I could not find a better one. So, and again, I highly recommend you read this. So this is on page 62 of your book, and here's the problem. We're going to max 20x plus 10y. And subject to the following constraints, we're going to have x greater than or equal to 2, and then y, and you'll see the problem right away, less than or equal to 5. And then, of course, x comma y greater than or equal to 0. Okay, this is the problem. Okay, so let's see what happens when we solve this. So here's x. Oh, what am I doing? Here's y. Need to keep that open, right? And then here, of course, are my, you know what? Why don't I just get smart and do what I did last? Whoa. There we go. Copy these. Copy. Paste. There we go. Okay, so what are my parameters here? 20, 10. Choice variables, just put in a 1 for now. The objective function, of course, is my sum product. There it is. Of my parameters and my choice variables. And you know, I should, if I haven't pointed this out, I apologize, but notice your choice variables are always in your sum product functions. Always, no exceptions, right? And then constraint 1, x. And then here it's y. Leave that open. So this is greater than or equal to, this one is less than or equal to. And they were equal to 2 and a 5. Okay, there we go. See it on the screen. And finally do my last two sum products. So, choice variables. Parameters of the constraints, hit OK. And I'm going to do the $ just to move this forward. There we go. A little quicker. Well, I've probably just blown the quickness bit right there. Okay, and nonetheless, here's the problem. So, you know, unbeknownst to us, our boss gives us this problem. We go into Solver, solve it. So we're going to do this, and we're going to maximize that function by changing these two cells, our choice variables. And of course, our constraints now is this number has to be greater than or equal to this number. And of course, this number has to be less than or equal to this number. Okay, check this box, simplex LP, hit solve. Uh-oh, another red exclamation point. Now it's saying that the objective cell values do not converge. This means that you have an unbounded problem. So what is going on here, right? I don't get a solution. So what happened? Well, just graphically, and you can see this in your book, but what's going on here now is we've got this situation. So here's our x variable, here's our y. So x has to be greater than or equal to 2, right? X has to be greater than or equal to 2. So here is 2. X has to be somewhere out here. But y has to be less than or equal to 5. Okay? Right? Well, what I'm trying to point out is this. It's unbounded. This, right? Here's my region. Right? Let me do this. Yeah. Okay. So just bear with me. All right, so this yellow region, right, is there. Get rid of that. Get rid of that. Of course, it erased the yellow, wouldn't you know it? So at any rate, this yellow region is my, satisfies all of my constraints, but it's unbounded, right? It just goes on and on and on. So you can never find a solution to this. This would be the problem, and I spoke about this earlier. This is the problem where the objective function really is being maximized at infinity, right? There are no values of x and y that solve this because they just go on forever, right? So the one way to think about this is the actual solution to this problem is you produce an infinite amount of x, right? And then I guess, well, y would be 5, but you could produce an infinite amount of x, right? And that's the problem. So this is an example of the unbounded problem that arises in linear programming. So, basically, just to be honest with you, you really have the two problems, infeasibility and unbounded, in which you actually can't find a solution. I personally think that the situation in which the slope of your objective function is the same as the slope of one of your constraints, I still view that as a problem because you cannot find a unique solution, right? And the problem is Excel just kind of assumes that you can't. And that's why I view that as being a problem. But nonetheless, even with that, you certainly can find values for x1, x2 that do satisfy that objective function, right? So anywho, there you go. There is linear programming in 7 relatively short videos. I certainly hope that helps. I want to encourage you, now that once you've seen all the videos, right, please ask me any questions in class that did make sense, and we'll go over that and just go from there. All right, well, that is it for the week 1 videos. I hope you enjoyed them, and I will see you in class soon.